Now, this is important because this is an overly sensitive test. Chi-square is too powerful at detecting difference. It's too powerful at detecting difference. And 2,000 is a large number. If we'd only had 300 subjects, we actually would have had a statistically significant value. And all we had to do was add one correlation. So maybe there was something between that item. So let's see, what was that item? It was, item 2 was, no, it was item 2. Item 2 is kind of wonky. Eager to learn is being attached to attentiveness. So say, look, it says, cannot concentrate on any particular task. Well, that's if you're easily distracted, you're not attentive. Lacks perseverance, not attentive. Easily frustrated, short attention span, not attentive. Aimless activity, purposeful. The one that seems most out of place is eager to learn, curious, and inquiring. Now, someone who is curious might be attentive to something, but that doesn't mean that it's still really not exactly the same thing, is it? Shows little interest, curiosity, and motivation in learning. I don't know. Of these 5 here, the one that was flagged as potentially a problem was number 2. So that's where we say, well, maybe we shouldn't use that value. Now, what did we have to do to keep it in there? We had to correlate it between 2 and 3. So impatience and lack of interest, we had to correlate. And then it seemed to come back and say, okay. So the other approach is to go back into our original model and say, well, wait a minute. Maybe we should just get rid of item 2. Maybe item 2 does well. Let me run this, and then we can call it this. That would be a good stopping point for here, actually. So let's go back to Stata. All right, let's go back to Stata, and again, let me zoom in on this so we can see a little better.
Some of these questions seem like they have a lot of covariance, right?
Some seem a little better.
Like, yeah, that some really are covering the same.
Yeah, I'd agree. Some seem to be, yeah.
So that should be portrayed in what varies with each other.
Mm-hmm.
So.
Yep. So notice I just took my SEM, the code, and I just deleted the Q3. And when I run this one, look at this one. I'm only going to focus on my chi-square here. My chi-square is 7.58, and my p-value is 0.0226. Now, I only have 2 degrees of freedom. So it's not like I can go around and start correlating lots of stuff to make this smaller. It's already pretty small. So this is where I would say, you know what, I'm probably happy with this, but let's take a look. Let's look at this, the goodness of fit stats. Here are the goodness of fit stats. RMSEA, 0.037, golden. CFI, 0.999, golden. 0.997 TLI, golden. You know what? The only thing that seems out of place here is my chi-square value. 0.7578. That's the only thing that seems out of place. Less than 0.05, less than 0.05, bigger than 0.995, bigger than 0.995. Hey, that seems pretty good. And technically, if I was using a cutoff of 0.02, which with an overpowered test doesn't seem reasonable, I wouldn't even reject. But let's take a look at that value, 7578. Let me go back and just borrow my Excel sheet. All right, now we have a chi-square of 7578. Is that what I just said? 7578. And our degrees of freedom is 2. All right. So now this says, if I've done this all correctly, let me scooch over there. This says I could have gone up to a sample size of 1630. So Something's not right. Oh, wrong degrees of freedom. That's why. There we go. All right, so with my sample of 2062, my chi-square is 7.578. If I divide it appropriately, I get my discrepancy function value, which is 0.0367 and change. That value, I could have taken up to a sample of 1/6. I could have had 1,600 values and would have obtained a non-statistically significant p-value, and I would have failed to reject the hypothesis, sigma equals sigma theta. All right, so that tells me, so in truth, here's what I could do. I could say, all right, let me randomly draw, I've got 2,000 values, let me randomly draw 1,200 of them. Let me do it a bunch of times and see how many times, if I draw 1,200, how many times do I end up with a matrix that actually says it's okay? If I do it 10 times and they all come out perfect, you know what? I'm just saying, randomly, one of the things you could potentially do is say, I'm randomly going to draw 1,200 of my values, run it, and see what it is. I'll report my statistics on the 1,200 I randomly drew. Okay? Though you very rarely don't want to do that. Because the chi-square is understood to be sensitive. So this number is, that's why we use this number. Okay?
Could you post this?
Sure, yeah. Let me save it right now so I don't forget. This is one of those types of, with these types of distribution functions, I have a tendency to delete them and forget about it. Or not save them and not forget where they go. So save as. Should be. So this one is, I'm going to call it the Hoelter. I'm going to go back and check that, the Hoelter N calculation. Hoelter, it's not Bentler.
Can we go back to the goodness of tip?
Yeah, of course. From on here.
Yeah. So is it a problem that our p value for our RMSA is non-significant, so that we're not confident that it's less than 0.05?
Right. So it's less than 0.05. So our RMSA is, the value we found was 0.037. So if we say that it's normally distributed, the probability that it actually is less than 0.05, well, since it's below, this distribution is, the estimating distribution is going to be centered at 0.037, which is clearly below. So it means over half of the curve is already below the 0.05 cutoff. This is just telling us how much of the area of the curve centered around 0.037 is below.
Okay.
So when it was above, like 0.7, we bring up one of the numbers from earlier. If we bring up one of the ones from earlier, okay. Right now, so what this picture is saying, right now my distribution is centered at 0.71. So here's 0.71. 0.073, excuse me, 0.073. So if I want to know how much of that is below 5, it's 0.016.
Okay.
So the more of this that's below, obviously if this curve goes below that, over half of it's going to be below.
Yeah.
That's what it's giving as the estimate. Okay. All right, so let me go ahead and stop the recording here. Hopefully the recording didn't get damaged when everything else got wonky. Fingers crossed. All right, have a good one. Stop recording.